people. Let's look at this question here. They're saying um, they're saying ADF is a tangent to circle with points E, B, C, and D on the circumference of a circle. AB is parallel to DC, and EC it is equal to DC. So in this case, the diagram has been drawn for us so that you can be able to see what they're talking about in the statement. Okay, so we do have the center on the chord DC, chord EC, and then we're told that DC it is equals to EC, right? And we're also told that AB is prior to DC. So in this case, guys, we are told that if CDF is equals to X, if this angle it is equals to X, we have to find with reasons 4 other angles equals to X. So in this case, angle E, our angle E here, it's basically not really angle E, but it's basically angle DEC, right? So it's angle DEC. So here there's supposed to be E2, E2 and E3, right? So angle this X it is close to angle E2. Angle E2 it is close to X. Why do we say angle E2 it is close to X? This is because this is tan chord theorem, okay? So it's basically tan chord what? Theorem. Okay. And then we are left with 3 of them. We are checking again. If we are told that EC it is equals to DC, it means we have an isosceles triangle, okay? So if this is an isosceles triangle, it means angle E2 it is equals to angle D2, which is equals to X, okay? Why do you say angle E2 is equals to D2 is equals to X? This is because we have angles opposite equal sides, right? And then another angle that we may talk about is what? Let's check. So we know that even this angle here is equals to this angle E2. And since we know that DC it is equals to EC, it means here we have equal chords which are subtending equal angles at the circumference. So angle E2 it is equals to angle B, okay? Because the chord EC subtend angle B and the chord DC subtend angle E2. So we are going to say angle E2 is equals to angle B, which is equals to X. Why do you say this? This is because we have equal what? Chords. Equal what? Angles. At the what? At the circumference of a circle, right? So they said we need to find 4 of them. So the last one in this case, it will be the exterior angle of a saddle part, because we know that this angle D1 or angle GX, it is close to angle B. Okay, so now we're going to use this angle D1. So we're going to say angle D1, it is close to angle D1, it is close to angle B, which is close to X. Why do you say this? This is an exterior angle of what? Of a cyclic quad. Okay, so we are done with finding the 4 angles, and then you get your 4 marks for such. Okay, so let's move to the next question. We are moving to the next question now. The next question, it will be let me check the next question here for you guys to okay. The next question is, let me see. The next question is something like this, and we have okay. They're saying now. This was question 5, right? They're saying O is the center of circle ABCDE with what? With angle DEC equals 26 degrees. Okay, our angle DEC is 26. So this is the angle they're talking about. This angle here. They're saying this angle here is 26. It's 26 degrees, right? And we are also told that AB, it is close to DC, and angle EOC, it is close to 106. So this angle is 106 degrees, right? It's 106 degrees. So now we need to calculate, give reasons, the size of number one. Number one, it's calculate. You can just say calculate. Give reasons, the size of number one, angle C1. Number two, it's angle A1. Number 3, it's angle OCD, right? So now let's check. If I told this O is the center, and then what determines C1? We need to determine this angle, our C1. Okay, our angle C1 in this case, guys, our angle C1, it is equals to what? It is equals to angle E3, because this is E, right? It's E1, E2, E3. So angle C1 is equals to angle E3. So this will be equals to 26 degrees. Okay. Why do you say angle C1 is equals to 26 degrees? Oh, this is because we have what? The chord AB, which is close to the chord DC. Let me say this D. Sorry for that. DC is a chord, AB is a chord, and they are equal. You have been told that from the statement, right? So it means that if DC is equal to AB, therefore we have what? We have equal angle subtended by equal chord at the circumference of a circle. So equal chords, equal what? Angles at the circumference. So even C1 is 26. To determine A1, A1 it is also easy as well. A1. So we do have this arc here. We do have arc. Let me see. We do have arc EC. This arc. So this arc here. This arc subtend which angle? This arc subtend angle O1 and angle A1. Okay, so these two angles are subtended by the same what? By the same arc. Right. So it means now we are going to say our angle A1 it is equals to half angle what? Angle EOC. Angle EOC is the angle at center, which is equals to 2 times angle at the circumference. So A1 it will be equals to 106 times half. So it will be 106 divided by 2 degrees. Why do you say this? This is because of angle at center. It is equals to 2 times angle at what? At circumference. Right. And then if that's the case, therefore you divide 106 by 2. So when we divide by 2, we are getting A1, which is equals to 53 degrees. Okay, so let's move to the last one, angle OCD. Our angle OCD we need to determine the whole angle of OCD, and that's saying this should give us 6 marks for determining the angle OCD. So OCD is this angle here. This is the angle they're talking about, right? This is the angle. This is the angle we need now. So we need to check. And determine this angle. So there are many ways to kill a cat, right? We can determine C3, okay? To determine OCD, we need to firstly determine C3. Or C3 is this angle here. This angle C3, okay? So angle C3, because OE and OC are equal, these are the radius. So we do have an isosceles triangle. So you're going to say angle EOC plus angle E2 plus angle C3. It is equals to 180 degrees. Angles of a what? Of a triangle. Okay. So now we have to calculate EOC. We know that EOC, it's 106 degrees plus E2 plus C3. E2 it is equal to C3 because we know that OC and OE are equal length, meaning OC is a radius and OE is a radius. So if these adjacent sides are equal, therefore C3 it is equal to E2. So we are allowed to say we have 2C3. 2C3, why? We've replaced E2 by C3 because they are equal. And then now we need to move, yeah? And then we say this 180 degrees. And then from this part now we can say 2C3 it is equal to 180 degrees minus 106 degrees. And then you need to divide by 2 both sides, right? So C3 it is equal to, so calculate 180 minus 106. 180 minus 106, you get 74 divided by 2, you're getting 37. So C3 is equal to 37 degrees. So here we got what? 37 degrees. So meaning that this will be 37 degrees and this will be 37 degrees. So if we are to add all these angles inside this triangle, we can get 180 degrees. So let's check. 106 plus 37 plus 37, you get what? 180 degrees, right? So now we know this angle. It means now we are to calculate angle C4. To calculate angle C4, we can use calculate angle C4. We can firstly find this angle here, angles around a point, okay? The angles around the point. So this angle here, it is given by 360 minus 106, which is 254, right? Meaning that if this is 254, it means our angle D here, angle D, it will be 254 divided by 2, which is 127. So this 127 degrees. If this is 127 degrees, then we can find C4 as sum of angles in a triangle. So we're going to say 26 plus 127, and then we get 153, and then we say 180 minus 153 are getting 27. So this angle here is 27 degrees. Therefore, the whole angle of COCD, it is cos 27 plus 37 degrees, which is cos 2. It is cos 2. This will give us 64 degrees. So this angle here, it's 64 degrees. We nailed it. And then we move to the next question, which is to prove that we need to prove that Okay, they are saying in the diagram, FH is a diameter. So FH is our diameter, okay? FH is the diameter of the circle FCH. FCH is the diameter of the circle FCH with the center O, right? So FC is a chord, and LCH is a secant. If that's saying FCH is a secant, the secant we're talking about, or let me say secant, like this. If they're saying say secant, LCH is a secant, it means the secant, it refers to a line intersecting a circle at 2 points. At 2 points. Okay? So it's a line intersecting a circle at what? At 2 points. Which point? C and H. Okay? So this line is a secant because it intersects the circle at C and at H. Right? So now they're saying LF, our LF is a tangent to the circle at F. And E, our E is a point on CH such that CE it is equals to EH. Okay. So now let me just wait for you guys to try and prove that FC is prior to OE. If you can prove this during the exam, you're going to get a distinction. During the exam, you are going to get a distinction. So let's just try to prove, guys. Let me just give you at least 2 minutes to prove and see if ever you can be able to write the correct Euclidean geometry solution. So let's see how you guys can tackle this question, because it's easy, as you can see, very easy. So let's try, please. I hope you guys managed to prove that FC is parallel to OE. Our FC is parallel to OE. And then F1 here, our F1 is X, okay? We're told that F1 is X. So if F1 is X now, we need to prove. How do we prove this? How do we go about this? We need to prove that angle E1 or E2 is 90 degrees, okay? So if you are to prove that angle E1 and E2 is 90, and we also prove that angle FCH is 90, therefore we have proved that FC is parallel to OE. So now this angle here it's 90. This angle is 90. Angle FCH, angle FCH, it is equals to 90 degrees. And then what do you say this? We do have a diameter FH, right? So therefore, this is because we have angle in same circle. Okay, it's angle in same circle. And then now we can determine angle E2 or angle E2. Angle E2, it is equals to angle E1 equals 90 degrees. Why do you say this? This is because we have a converse of theorem number 1, which states that a line drawn from center bisect a chord and is perpendicular to the chord. So you can just write line from center bisect the chord perpendicular to the chord. Perpendicular to the what? To the chord. Line from center bisect the chord perpendicular to the chord. So this is 90 degrees, okay? So now we do have corresponding what? Angles. So E2 this goes to FCH. 90 degrees. So these are what are corresponding angles. Corresponding what? Angles. So now since we know that E2 and angle FCE is 90, or angle FCH is 90, therefore you can say FC is parallel to what? To OE. Done. So we are done with this question, guys. It was easy. And then we can move to the next question if ever we still have some. The next one here, it was proving the Tan-Codd theorem, which we have proved several times, okay? So we do have question number 2. All right. Let's move to question number 2. Question number 2, it's all about trigonometry, right? It's all about trigonometry. Now they're saying we need to determine the general solution of 2 cos theta. It is equals to this 2 theta. 2 cos 2 theta, it is equals to negative 0.44. So in this case, if we have 2 cos of 2 theta equals to negative 0.44, we need to divide both sides by 2. And then remain with cos 2 theta, it is equals to 0.44 divided by 2. 0.44 divided by 2. We're getting 0.22, negative 0.22. And our reference angle here, reference angle, this goes to cos 0.22. It's negative. And then you say shift cos 0, negative 0.22. By getting 102.7 degrees. And then now the solution will be 2 theta, it is equals to plus or minus 102.7 degrees. 102.7 degrees plus 306 degrees times k. And then now we divide by 2 both sides. So this will be theta equals to 102.7 divided by 2. Which is plus or minus 51.4 degrees plus 180 degrees. Times k, where k is an element of all what? Integers. We're done with this one. And then we move to the next question, whereby they are saying you need to prove that tan of theta minus sine of theta divided by 1 minus cos of theta equal to tan of theta, right? So we need to prove that the left hand side is equal to the right hand side. So you need to choose the most complicated side between the two. So in this case, the complicated side is the left hand side. So I will just copy the left hand side by 1 minus cos of theta. In this case now, we need to remain with cos. We need to remain with cos here. So it's basically 1 minus cos of theta. So I'm going to change this into its fundamental identity, which is sine of theta divided by the cos of theta minus sine theta. So this should be divided by 1 minus the cos of theta, okay? So from this part now, we know that this can be divided by 1, right? So you can simplify the fractions between these two. So in this case, you're going to say the cos of theta times 1, and then you do the Pirates method, because here it's k is achieved, which is 2, like this. You multiply the denominators, and then you get the cos of theta. And then from this part now, you multiply sine theta and 1. You're getting the sine of theta, cross multiplication, okay, minus the cos times sine. So this will be sine theta multiplied by the cos of theta. So basically, why am I saying chiefs and pirates? This is because we have these two, we multiply these two, right? After multiplying the denominators, you move to the cross multiplication. You cross multiply these two like this. Just cross multiply them, and then you remain with what I've written here. And then you multiply by what? You're going to multiply by 1 divided by 1 minus cos of theta, because we have to flip the values, right? And this is a binomial. The numerator is binomial, so you need to take out the common factor. The common factor here, it will be sine theta open bracket 1 minus cos of theta divided by cos theta multiplied by 1 divided by 1 minus cos of theta. So this will cancel, and then you remain with what? You remain with sine times 1. It's sine theta divided by the cos of theta, and then remain with tan theta, which is correct. So since we've proven that this expression here will be equals to the tan of theta, therefore you conclude by saying left hand side is equals to the right hand side. Proven. And then now we move to what was the next question here? To simplify. But this one you guys can simplify. It's easy. Let me just write it for you, and then you will simplify alone at home. You are given cos, basically cos of 90 plus x multiplied by sine of 180 plus x plus divided by tan 225 degrees minus cos squared minus x. So please guys, try to simplify. Simplify. Need to simplify this expression. So let's try to simplify. write the correct answer. Thank you very much. Night.